Alright, this is the solutions video for the extra practice problems on page 563. This will cover problems 1 through 5. Of course, we are in chapter 1 here. So I'm not going to put the book underneath the camera. Just going to kind of read through it since there are no graphs in these problems. So number 1 says a person's standing on the edge of a 30-foot cliff, throws the ball straight up into the air. If the ball travels 50 feet up and then falls to the bottom of the cliff, what would be the total distance traveled and what would be the displacement of the ball? Okay, so let's draw what we've got here. Let's say we've got a cliff and it's 30 feet. Okay, and the ball goes up 50, down 50, and then hits the ground. So we're going 50 feet up and then 50 feet back down. So the total distance is going to be 50 plus 50 plus 30 from the base of the cliff, or excuse me, from the top of the cliff to the base of the cliff. So that's going to be 130 feet. All right, and so what is the displacement? Well, the displacement is just going to be from here where it started to here where it finished. And if we're going to define the positive direction as up, okay, then the displacement, which is a vector, is going to be minus 30 feet. So that minus sign is really important since we are going down. All right, number 2 says it takes an infant 3.5 minutes to crawl the 22 meters from the playpen to the refrigerator and 11 meters back towards the playpen. What's the infant's average speed and average velocity? Okay, so we've got an infant that travels 22 meters, that's pretty far, and then back another 11 meters. All right, so what is the average speed? Well, speed is the change in distance over the change in time, and the change in distance is going to be 22 plus 11 meters, that total distance, and it's 3.5 minutes. All right, so 33 divided by 3.5 is going to give you 9.43 meters per minute. All right, but the velocity is the change in displacement over the change in time. And that's just going to be from here, let's call this point A, to here, point B. The shortest distance from where you started to where you ended up. So that'd be 22 minus 11. Still took 3.5 minutes. All right, and that is 3.14 meters per minute. All right, number 3 says a runner's average velocity over a race of 600 meters is 0.61 meters a second. Since the race was run on an oval track, the displacement is 62 meters. How much time did it take the runner to run the race? Okay, well, we're not really worried about distance because we only care about displacement. And you know that velocity is change in displacement over change in time. If we want to know how long, we're solving for delta t, so we will switch those two. That's our algebra. Delta t is the displacement over the velocity. All right, so our displacement is 62 meters. Velocity is 0.61 meters per second. And that is 101.64 seconds. All right, so that gets the first three out of the way. Okay, so pause the video if you need to, and we'll do 4 and 5. All right, number 4. Number 4 is tricky because it involves a conversion. All right, it says, while driving, a man slows his car from 72 to 65 miles an hour in 1.8 seconds. What's his acceleration in miles per second squared? All right, we know acceleration is the change in velocity over the change in time. And that's going to be the final velocity minus the initial velocity over the change in time. We're given for these two values miles per hour. All right, and we want to know miles per second squared. Okay, so our change in velocity is equal to the final velocity, 65, minus the initial velocity, 72. There's a messy 6, sorry. 65 minus 72, that's negative 7 miles per hour. I need to change that to miles per second. So we're going to use that factor label method that we used in chemistry, minus 7 miles per hour. And then I want to go to miles per second. So I put the unit I want to get rid of on top, which is hours, and I want seconds on the bottom. The 1 goes by the bigger one, and there's 3,600 seconds in an hour. So that's going to be minus 0.0019 miles per second. Okay, now we can use that to get acceleration. So acceleration is minus 0.0019 miles per second divided by 1.8 seconds. And that will give you minus 0.0011 miles per second squared. All right, if you missed that because you didn't do the unit conversion, you left this in miles per hour, you know, this is a good problem to remind you to pay attention to the units and be careful. You will, on the test, have to do some unit conversion for sure. Okay, number 5. What would be the final velocity of a car that is initially moving at 62 meters a second and accelerates at negative 5 meters per second squared for 9.2 seconds? All right, so we just want to fill in our equation. Again, acceleration, change in velocity over change in time. All right, so acceleration, therefore, so we've got acceleration is negative 5 meters per second squared is equal to the final velocity is what we're trying to get. So we leave that as the variable. The initial velocity is 62. All right, and it's 9.2 seconds. Okay, so we'll multiply both sides by 9.2 seconds. I normally wouldn't show this step. That's okay. Final velocity minus 62 meters per second. It's early in the year, so you gotta get back used to doing the algebra. Okay, negative 5 times 9.2 is negative 46 is equal to the final velocity minus 62. So we're going to add 62 to both sides. And we're going to have, what's that, 16 meters per second is equal to our final velocity. So didn't slow to a stop. Slowed down to 16 meters a second. All right, that's first 5 of your extra practice problem, which is basically the math portion of your test review. And we'll take a look at the solutions for number 6 through 10 on the next video.